Hey everybody, my name is Hailey Parikh and I'm a junior majoring in physics at Rutgers University. Today I will be talking about my research poster. Over the past few months, I have been working with the relativistic heavy ion group at Rutgers. My task was to run Monte Carlo simulations to investigate jet shape variables at the relativistic heavy ion collider, that is RHIC. It is known that relativistic heavy ion collisions at the Large Hadron Collider, that's the LHC, and at RHIC result in the formation of a strongly coupled medium called the quark-gluon plasma, that is QGP. QGP has been theorized to exist a mere 20 microseconds after the Big Bang. We can study this medium using internal probes called jets. Jets are streams of high momenta particles that form as a result of QCD hard scattering processes in the early stages of the collision. This cartoon schematic right here shows the formation of a jet emerging from a proton-proton collision. The decay products of the jet are measured using calorimeters, as shown here. Jets strongly interact with the QGP medium and lose energy as they traverse through it in a process called jet quenching. That's why jet observables can illuminate the properties of the medium. Several jet variables have already been investigated at LHC energies. For instance, the jet shape. Jet shape is the radial distribution of the fractional transverse momenta from the jet axis. Figure 2 over here shows CMS jet shape measurements for lead-lead collisions. Jet shape changes in more central collisions due to the strong interactions of jet constituents with QGP. Jet charge is another such variable. Jet charge is the momentum-weighted sum of the charged jet constituents. This figure over here shows CMS jet charge measurements for kappa, which is the independent parameter, equal to 0.6 for proton-proton collisions. As seen over here, they match the Monte Carlo simulations very well. Jet mass is another such observable, expected to be sensitive to the QGP. However, in this plot here, we see that it matches Monte Carlo simulations for both quenched and unquenched jets. Therefore, it is essential to study this at RHIC energies with low jet PT to disentangle these effects. In this study, I have used root framework to analyze dijet events generated by Pythia for proton-proton collisions at a center of mass energy of 200 GeV. Jets were reconstructed using the anti-KT algorithm with a resolution parameter of 0.4. Cuts for the constituents and the inclusive jets were applied, as given here. These selections are made for RHIC energies. This figure here shows the jet PT distribution. Now, on to discussing the results for the jet shape variables. As you can see in this figure, the jet shape distribution falls steeply as you get away from the jet core. This is because most of the jet PT is concentrated in the vicinity of the jet core. Jet charge distribution here is calculated with kappa equal to 0.5. The jet mass distribution shown here is narrower than the jet mass distribution observed at the LHC, which we saw in this figure right here. This is because of the different kinematic ranges of the jet PT at the LHC and at RHIC. Jet charge and jet mass together can constrain the flavor of the initiating parton for the observed jet. I included a correlation plot over here for jet charge and jet mass. My goal is to further investigate this correlation with various PT ranges. Essentially, this research project centers on determining whether these jet shape variables are actually convoluted. Presented in this poster is only a primary analysis. We plan on extending this study by covering the full jet PT range for RHIC energies, investigating the given jet shape variables within different PT ranges, varying the permissible constituent PT for the jet definition, exploring the dependence of jet charge on the kappa value for jets initiated by different partons, and finally, exploring the correlation of jet shape dependence on jet mass and jet charge. Finally, I would like to thank Professor Sevi Salor of Rutgers University for taking me under her wing, and the Rutgers Relativistic Heavy Ion Group for their constant support and mentorship. Thank you.